this video, we will look at solving equations that have absolute values in them, both equations and inequalities, things with less than or greater than symbols in them. Remember that absolute value is equivalent to the distance from zero. So when I have an expression that says that the absolute value of something is equal to a particular number, that means that it is equal to either the positive value or the negative value. As an example, if I said that the absolute value of x is equal to 5, that means that the distance from that number x is 5 away from the origin. So that could either be at 5 or that could also be at -5. We end up getting two possible solutions because this distance is the same. Even if we have an expression like these, this is just in the place of some number that we don't know what it is. But that particular number has a distance of 1 away from the origin. So we'll say that either 3x plus 2 is equal to 1. That would be if it's on the positive side of 0. Or we could say that that number is equal to -1. That's if it's on the negative side of 0. Those would both be equivalent to a distance of 1 away from 0. So I'll solve each of these two equations separately. Start by subtracting 2 from both sides, and then dividing by 3. So this will be one solution that I'm getting -1/3, or again subtract 2 from both sides, and then divide by 3 to get that x is equal to -1. These are two numbers that if I put them into the expression, they would end up making that expression exactly 1 unit away from 0. Let's look at a second example. In this example, before we get started, we want to move this 1 away from the absolute value sign. So we'll start by subtracting that 1 from both sides before we break the absolute value into two sides. The number that's inside the absolute value symbol is a distance of 6 away from 0. So that could either be that this expression is equal to 6, or that this expression is equal to -6. Solving the one on the left, I'll add 3 to both sides, and then I'll divide by 4 to get one of my solutions. To solve the one on the right, I'll add 3 to both sides, and then dividing by 4 again, I get -3/4. So these are my two solutions. The next set of examples involve an inequality. And rather than being an exact distance from 0, it is within some particular range. If the absolute value is less than a particular number, let's say that a is here and -a is here. If the absolute value is less than a, that means that all of the possible solutions are within this range. For the second example, if I say that the absolute value is greater than some value, then that means that it's outside of this range. And so I'm getting that the values are going to be either greater than a or less than -a. Let's do some examples. Let's consider the absolute value of x plus 8 being less than 9. that falls into the first category, where x plus 8 is either less than 9 or x plus 8 is greater than negative 9, somewhere in between the positive and the negative value. I'll solve these both separately. Subtract 8 from both sides for the left-hand equation or inequality to get that x is less than 1. For the one on the right, subtract 8 and we get that x is greater than negative 17. If we want to graph our solution, we're saying that x is either greater than negative 17 or less than 1, so anywhere in that set. We could also write this as going from negative 17 to 1. Let's look at a different example. Let's consider the absolute value of 2x plus 3, and let's say that it is less than or equal to 9. That means that this expression is either less than or equal to 9, or it's greater than or equal to negative 9. Again, because the absolute value is in between the positive and the negative, it's less than those two outer bounds, and so it's sandwiched in between the two. We solve these two inequalities separately. Let's subtract 3 from both sides to get 2x less than or equal to 6, and x is less than or equal to 3. On the right, 2x is greater than or equal to negative, this should be a plus, right? Negative 12. And x is greater than or equal to negative 6. Putting that together on a graph, we're getting values that are greater than or equal to negative 6 and less than or equal to 3. Let's do 2 more examples where the inequality is going the other direction. Suppose that instead we look at a particular number and it is greater than or equal to 8 in its absolute value from 0. What we mean by that is that it's going to be here or here. It's on the outsides. So looking at this picture that I've drawn, I know that one of the equations will be that 6 minus 4x is going to be less than or equal to negative 8. That's this part right here. Looking at the other part, I get that 6 minus 4x is greater than or equal to 8. The distance is farther away than 8 from 0. I'll solve these independently. For the one on the left, let's subtract 6 from both sides. And when I divide by a negative number, remember that's a reflection, and so what it does is it flips everything to the other side of the number line, and the order changes. Large to small changes its order. So when you divide by a negative sign, you change the sign. You change the sign in the center. So this becomes x greater than or equal to 7 over 2. For the equation on the right, again, we will subtract 6 from both sides. And then, similarly to the first one, we divide by negative 4. And we get oops, I need to switch that sign, right? Switch that to the other direction. I get that x is less than or equal to -1/2. Looking at this on a number line, I'm having things that are less than or equal to -1/2 or greater than or equal to 7/2. So going from -infinity to -1/2, close bracket because we're including the endpoints, and then going from 7/2 to +infinity. All right, one more example. Let's consider 2x plus 1/3 greater than 5. I want the distance of this expression to be larger than 5 from 0. So we take the expression as it is and write it without the absolute value signs, or we take the expression, we flip the sign, and we change the number to be the opposite, or with a negative sign in front of it. Like we were looking at in the last video, to solve an expression like this, it's helpful to clear denominators. So if I multiplied both sides by 3, I'll have 2x plus 1 greater than 15, 2x greater than 14, and x is greater than 7. On the right-hand side, 2x plus 1 is less than -15. 2x is less than -16. X is less than -8. I never divided by a negative number here, so I don't need to change the signs at all. Looking at the number line, I'm getting values that are greater than 7 or less than -8. So going from -infinity to -8, and from 7 to +infinity. If you have questions, you can send me an email or make an appointment in office hours, and I will see you in class.